So now that we've gone through all the basic differentiation concepts for the rules for, we've dealt with negative indices, we've dealt with fractional indices, now we've dealt with fractions, we've dealt with um, functions that you add, we're adding functions and things like that. So now that we've looked at that, we're going to look into more of a complex rule, but something that also forms is very foundational to the concept of differentiation, and that is the chain rule. And when we're looking at the chain rule, we're basically looking at how to differentiate sort of more complex functions, functions that have that are made up of, you could say, multiple functions. For example, what I'll do is just looking at this first question here, y is equal to x squared plus 1 to the power of 7. So far we've looked at questions like how to derive something like x to the power of 4 plus 1, or we've looked at deriving functions like y is equal to x to the power of 6. So what the chain rule will allow us to do is it will allow us to say, okay, what if you have a function that combines these two? What if you have something like x to the power of 4 plus 1 to the power of 6? How do we derive that? Okay, and that is basically what the chain rule is going to teach us. And through these three examples, I'm going to aim to explain to you the rule, what the chain rule is, and how we can use it to sort of go through and derive these more complex functions per se. So I'm gonna in all these three of these questions, I'm gonna use this rule that we have, so you guys can get a good understanding of the formula and the rule itself. And that in future videos, I'll explain how we can get shortcuts, and you guys can become a bit more efficient into solving these more complex questions as well. So looking at the first one, we've got y is equal to x squared plus 1 to the power of 7. Okay? Now, up until now, when we've been dealing with powers, what we've been doing is we've been doing expansions, right? And that's mainly because we've been dealing with quadratics. We've been saying, okay, if we've got a function like x plus 3 squared, now how can we derive that? We just expand it. So we expand it, and you get x squared plus 6x plus 9, and then you can just derive each of these terms by itself. Right? But when you have something to the power of 7, if you go about expanding that, that's going to take you a really long time. Okay? It's obviously not feasible, and we just have an easier way of doing it. So what we're going to say is we're going to use this rule, and it may seem confusing as of now, but it's actually really simple, and it's going to make real sense. So what we do is, what you need to identify that this is basically a function inside a function, right? So what we're doing is we've already got a function, so the function of x squared plus 1, and to that function we're applying something else. We are powering that to the power of 7. So what we're going to do is, when I ignore this 7 for now, and we're just going to look at this x squared plus 1. So what I want to say is, let u equal x squared plus 1. Okay, so we're just giving it another word. Okay, so instead of a whole function, now we just have singular letter. So if u is equal to x squared plus 1, then our y, we can rewrite this y function as y is equal to u to the power of 7. Okay? Now, using that notation, remember what I said about what this means. When we have dy over dx, that means what we're doing is we are deriving our function y with respect to x. Okay? So we're deriving the actual x expressions. And to do that in a chain rule, what we do is we make up another function. So we realize that there's a function inside the function, and we can call that function u, okay, which is what we've done here. Then what we do is we find the derivative of u, so that's du over dx, and then we find the derivative of y in relation to u, that's dy over du. And when you multiply them together, if you just think of it as a fraction, this and this cancels out, and you're left with dy over dx. Right, so that's what we're aiming to be up. So we've got these two functions. So what we're going to do is we're going to derive each of these. Okay, so we know how to derive u is equal to x squared plus 1. So if we have u is equal to x squared plus 1, we know how to derive that. So du over dx is just equal to 2x. Okay, so we're going to save that, and we're going to keep that. So that's our du over dx that we need over here. And then for our y is equal to u to the power 7, again, we're going to derive that. So over here we have y, and what's in our input? It's u. So we're going to derive that with respect to u. And that, again, we know how to derive that. We bring the power down, subtract the power by 1. 7u to the power 6. So now, to find the derivative of this actual expression, right, which is that dy over dx, that will become dy over dx is equal to dy over du, which is 7u to the power 6, times du over dx, which is 2x. And that basically is 14x u to the power of 6. And now what we do is we put our u back. So what we said, remember we said that our u was x squared plus 1. So that means we got 14x x squared plus 1 to the power of 6. And that is your derivative. So basically what we're doing is we're just splitting up the function. We're realizing that there's, a function within that function, which we're going to derive first. And then, you break it up into these two parts and you put them together, and then you get your final derivative. It's a pretty cool concept. So maybe I'll try doing the second result. Try pausing the video and try it yourself, and then come back with the explanation. So, if you guys have tried it, what we're going to do is we're going to go through it now. So, same thing. Y is equal to 2x plus 3 to the power 4. So again, what we can do is we can realize that the function that we have inside is 2x plus 3. Okay? So if u is equal to 2x plus 3, our du with respect to x, so our derivative of u with respect to x is just equal to 2. Okay? And then if we're letting u equal to 2x plus 3, we know that y is equal to 5, and then instead of 2x plus 3, we have u to the power of 4. That looks too much like a 4. Just gonna rewrite that. It's a u. Again, I'm gonna rewrite this 4 as O, because I do not want to be confused. When you're in a stressful situation in exam, these things can happen. So be very careful. Okay, now we're deriving y with respect to u. So again, putting the power down, 5 times 4 is 20, and we reduce the power by 1. Okay, now that we've got that, so now we know that dy or dx is equal to dy over du times du over dx. Okay, so what's our dy over du? Our dy over du is this, 20u to the power of 3. And our du over dx is 2. Okay, so putting that together, that is equal to 20 times 2 is 40, so we've got 40u to the power of 3, and then subbing back our u as 2x plus 3, so 42x plus 3 squared is our answer. Okay, so it's not that difficult, guys. Just an extra step involved. But just really try to understand this format and what we're doing with, finding that function inside. And yeah, just really sort of understand this, because this is really crucial. And that's why we sort of introduced those different notations of derivatives. That's why we just don't use, say, if our function is y is equal to this, if that's our function, that's why we always don't just write y dash, right? Because in situations like these, you want that more information. You want to know that we're deriving y with respect to x. So that's why we'll be exploring the different notations. And if you haven't looked at those videos, then do look at those first, and it's going to make a lot more sense for you in this video as well. Okay, and now we're going to go through the same thing for this last question. Again, feel free to pause the video and try it yourself, and then come back. So f of x is equal to negative 5 x cubed plus x plus 1 to the power of 6. Okay, so again, we've got our function inside. So we're going to say, oh, actually, let's erase this. So we've got our function here. So let's say, let u equal x cubed plus x plus 1. Okay? Which means that our f of x is equal to -5 u to the power 6. Okay, now let's derive u. So du over dx is equal to 3x squared plus 1. Okay, now see what I was talking about earlier. See how the other equation had a y. So we're able to widen this one. But over here, we've got an fx. So what I like to do in these situations is I like to say that, so for example, if this is our equation, I like to say fx is equal to this is equal to y. So we're just giving another name for the function. So instead of fx, we can just write it as y. And I just like doing that because then it just becomes a lot easier to show it in this notation, which I think is crucial when you're doing the chain rule. So now we can say dy over du is equal to -30 u to the power of 5. Okay, and therefore our dy over dx is equal to du over dx times dy over du. Now du over dx is equal to 3x squared plus 1. And dy over du is equal to -30 u to the power of 5. And our u is x cubed plus x plus 1 to the power of 5. So rewriting that, you would be -30 x cubed plus x plus 1 to the power of 5 and 3x squared plus 1. Now, what I'll do is, so that's our answer. See if you guys can notice anything interesting about the solution, because this is something that we're going to look at in future videos as an extension, not an extension of the chain rule, but when we look at shortcuts of the chain rule, so we don't have to use this formula every time. See if you guys can notice anything about this. I'll give you guys a hint. Think of these two expressions here, and just in the comments, just let me know if there's anything that you can sort of figure out, anything that you realize, anything that's related between the two of them. If you do, put in the comments below. Otherwise, we'll go through them in the next videos. And yeah, that's just basically an introduction of the chain rule, and how we can go through these more difficult or more complex function derivings.